Picture this, it's the 27th of August, 1939. 6 days before Germany invades Poland. 6 days before the world descends into the most destructive conflict in human history. At the Heinkel Aircraft Works in Rostock, a small, strange-looking aircraft sits on the runway in the pre-dawn darkness. It has no propeller. Its engine, buried inside the fuselage, makes a sound unlike anything anyone at that airfield has ever heard. A high-pitched whine that rises and rises until it sounds less like machinery and more like the future arriving ahead of schedule. Test pilot Erich Warsitz climbs into the cockpit. He's already tested some of the most dangerous experimental aircraft in Germany. He's been told this one is different. This one works on completely different principles from anything that has flown before. He advances what passes for a throttle. The aircraft moves. Accelerates. The tail comes up. And then, almost casually, it lifts off the runway and climbs into the Baltic dawn without a propeller turning anywhere. The jet age has just begun. And almost nobody knows about it. Not the German public. Not the Luftwaffe leadership, who were invited to watch the flight and didn't bother showing up. Not the Allied intelligence services. Not even most of the engineers at Heinkel who weren't directly involved in the program. What Erich Warsitz does on that August morning is arguably the most consequential few minutes in the history of aviation. He proves that jet propulsion works. That you can build an aircraft powered entirely by the reaction of hot gas through a turbine, with no propeller, no piston engine, none of the machinery that aviation had depended on since the Wright brothers. And then the German military looks at his achievement, shrugs, and does almost nothing useful with it for 3 years. This is the story of the Heinkel He 178. The aircraft that started everything and got credit for almost nothing. The beginning of a dynasty that its creator never got to lead. The man behind the machine. Ernst Heinkel was not a modest man. He knew he was brilliant and he was comfortable saying so. By 1939, his company had produced some of the most significant aircraft in German aviation, the He-51 biplane, the He-111 bomber, dozens of designs that had established Heinkel Flugzeugwerk as one of the premier aviation manufacturers in Europe. But Heinkel was always looking for the next thing. The thing that would make everything that came before it obsolete. In 1936, he heard about a young physicist at Göttingen University named Hans Joachim Pabst von Ohain who had filed a patent for a jet propulsion device. Not the first such patent, Frank Whittle in Britain had filed his own jet engine patent in 1930. But von Ohain's design had specific characteristics that Heinkel's engineers thought might actually work. Heinkel hired von Ohain immediately. Gave him a team, a budget, and a facility. Told him to build something that flies. Von Ohain was 24 years old. What Heinkel understood, and what the German Air Ministry consistently failed to grasp, was that jet propulsion wasn't just a different way to make an engine. It was a different way to think about flight. A jet engine has no propeller torque, no complex reduction gear, no pistons hammering up and down thousands of times per minute. It's elegantly simple in concept: compress air, add fuel, burn it, expel the hot gas, and extraordinarily complex in execution. The execution was what von Ohain spent 3 years working through. The early test engines exploded, melted, vibrated themselves apart. The compressor stages couldn't maintain the pressure ratios needed for efficient combustion. The turbine blades dissolved in the heat they were supposed to survive. Each failure taught something. Each explosion was data. By late 1938, von Ohain had an engine, the He's 3B, that ran reliably enough to contemplate putting it in an aircraft. It produced approximately 1,100 pounds of thrust. By comparison, the piston engines powering contemporary German fighters produced equivalent thrust values that aviation engineers spent considerable time arguing about, but the jet's thrust came without the vibration, the weight penalty of a reduction gear, or the aerodynamic drag of a propeller. Ernst Heinkel, characteristically, didn't wait for permission. He told his design team to build an aircraft around the engine immediately. Designing the impossible. The engineering challenge of designing an aircraft around a jet engine in 1938 was extraordinary, because almost nothing was known about how such an aircraft would behave. Piston engine aircraft design had accumulated 4 decades of knowledge. Engineers knew how propeller wash affected the tail surfaces. They knew how torque influenced handling. They knew the relationship between engine power and aircraft performance with considerable precision. With a jet engine, they knew almost nothing. There was no accumulated experience. No database of comparable designs. No pilots who had flown anything like it and could describe what the handling characteristics were like. Heinkel's chief designer for the project was Siegfried Gunter, one of the most talented aircraft designers in Germany. He approached the problem with elegant simplicity: make the airframe as small as possible around the engine, minimize complexity, keep the design conventional enough that a pilot with normal training could fly it. The result was the He 178. It was tiny, just 24 feet long, with a wingspan of just under 24 feet as well. Nearly square in planform, which looked slightly odd but simplified the structural design. The engine was mounted in the fuselage with the intake in the nose, a simple, direct arrangement that maximized the efficiency of the air path through the engine. The exhaust exited beneath the tail. The cockpit sat above the engine, giving the pilot a reasonable view forward. The landing gear was fixed and non-retractable, which added drag but saved the weight and complexity of a retraction mechanism. This was a research aircraft, not a combat aircraft. Drag was acceptable if it simplified the design. The wings were mid-mounted, which was aerodynamically clean and provided good stability. The construction was conventional, aluminum alloy stressed skin, built with the same techniques Heinkel's workers used for every other aircraft in the factory. It wasn't radical in any way except the most fundamental way possible: there was no propeller. The first flight on August 27, 1939, lasted about 10 minutes. Warsitz reported that the aircraft handled adequately, though the controls were somewhat heavy and the landing gear made the approach faster than ideal. The engine performed without incident. 10 minutes of flight. Barely enough to circle the airfield and come back. But those 10 minutes changed aviation forever. The military's spectacular indifference. Here is where the story takes the turn that has baffled historians ever since. Ernst Heinkel immediately recognized what his team had accomplished. He contacted the Luftwaffe and the Air Ministry. He invited senior officials to see the aircraft. He wrote reports explaining the revolutionary nature of what Heinkel had achieved. The response was, by any measure, extraordinary in its inadequacy. Ernst Udet, the World War I ace who was now in charge of Luftwaffe aircraft development, came to see a demonstration in November 1939. He watched the He 178 fly. He asked some questions. He left without placing any orders or initiating any development programs. His reported comment was that jet aircraft were interesting but not immediately relevant to Germany's military needs. Germany was winning the war with conventional aircraft. The Bf 109 was superior to any fighter it had yet encountered. The He 111 and Dornier Du 17 were bombing Britain into submission. What exactly did Germany need a jet for? This reasoning was not entirely stupid. In the autumn of 1939, Germany's military position was genuinely strong. Poland had been conquered in weeks. France hadn't yet been invaded. Britain was fighting defensively. The Luftwaffe with its existing equipment was a formidable force that had not yet met its match. But it was catastrophically short-sighted. The jet engine didn't just offer incremental improvement over piston engines. It offered a generational leap. Aircraft powered by turbojets would be fundamentally faster, could fly at fundamentally higher altitudes, and would eventually be fundamentally more reliable than anything with pistons and propellers. The nation that developed operational jet aircraft first would have an enormous military advantage. Germany had that advantage in August 1939, handed to them by Ernst Heinkel and Hans von Ohain. And they spent the next 3 years doing almost nothing with it. The parallel development. While the Air Ministry was studiously ignoring Heinkel's achievement, something was happening across town at Messerschmitt. Willy Messerschmitt had his own jet engine development underway, working with the Junkers Engine Company on the Jumo 004 turbojet. This program was technically more ambitious than von Ohain's He's 3, the Jumo 004 aimed at significantly higher thrust levels and was designed from the outset as a production engine, not just a research device. The Messerschmitt airframe design that would eventually become the Me 262 began in 1939, the same year the He 178 flew. But it faced years of delays, engine problems, aerodynamic issues, resource allocation battles within the Luftwaffe procurement system. What's remarkable is how little the He 178 achievement benefited the Me 262 program. The knowledge gained from actually flying a jet aircraft, the handling characteristics, the engine response quirks, the completely different throttle management required compared to a piston engine, should have been invaluable to Messerschmitt's designers. Instead, Heinkel and Messerschmitt operated largely in parallel, with limited knowledge transfer between programs. The German aviation industry's tendency toward institutional competition rather than cooperation meant that Heinkel's hard-won jet flight experience was not systematically shared with the engineers who most needed it. This is one of the great might-have-beens of World War II aviation. If Germany had treated its jet aviation programs as a national priority in 1939, pooling the knowledge from Heinkel and Messerschmitt, the Me 262 might have entered operational service in 1942 or 1943 rather than 1944. The implications for the air war over Europe would have been profound. The He 280, the forgotten fighter. While the He 178 was making history and being ignored, Ernst Heinkel was already thinking beyond it. The He 178 was a research aircraft. What Heinkel wanted to build was a jet fighter. The result was the He 280, and this is where the Heinkel jet dynasty story becomes genuinely tragic. The He 280 was everything the He 178 was not. It was designed from the ground up as a combat aircraft. Twin engines mounted in underwing nacelles, the same basic layout that the Me 262 would later use. Retractable landing gear. An enclosed, pressurized cockpit. Armament provisions. Combat range. It first flew on April 2, 1941, a full year before the Messerschmitt Me 262 made its first powered jet flight. The He 280 was, in the opinion of its test pilots, an excellent aircraft. It handled well, it was fast, and its twin-engine configuration gave it reasonable safety margins if one engine failed. In a simulated combat test against a Focke-Wulf FW-190, then the best piston engine fighter in Germany, the He 280 won decisively. It should have been ordered into production immediately. Instead, the Air Ministry chose the Me 262. The reasons were complex and disputed. The Me 262 was designed around the more powerful Jumo 004 engine, which promised better performance than the He 280's He's 8 engines. Messerschmitt had better political connections within the Luftwaffe procurement system. There were genuine technical concerns about the He 280's engine reliability and range. But the decision cost Germany at least a year of potential jet fighter operational experience. The He 280 was ready for production in 1941. The Me 262 didn't enter operational service until 1944. 3 years during which Germany's enemies were rapidly closing the gap in conventional aviation capability. Ernst Heinkel was furious. He believed, not without justification, that political factors had overridden technical merit. He believed the He 280 was a superior combat aircraft to the Me 262 in several important respects. He was not wrong about the aircraft's capabilities. He may have been wrong about the engine situation, which was genuinely problematic. The He 280 program was cancelled in March 1943. The aircraft that had beaten the FW-190 in simulated combat, the aircraft that had flown operationally a year before the Me 262, was scrapped. The legacy of the He 178. What did the He 178 actually achieve? Not in terms of its direct military impact, which was essentially zero, but in terms of what it proved and what it set in motion. First, it proved that jet propulsion worked as an aircraft powerplant. This sounds obvious in retrospect, but in 1939 it was genuinely uncertain. Von Ohain and Whittle had built engines that ran on test stands. Nobody had demonstrated that a jet engine could power a complete aircraft through the full flight envelope, takeoff, climb, cruise, descent, landing, without catastrophic failure. The He 178 demonstrated exactly this. Second, it provided the first practical data on jet aircraft handling characteristics. The He 178 was not a sophisticated aircraft, but flying it taught Heinkel's engineers and pilots things about jet propulsion that couldn't be learned from engine test stands. How the aircraft behaved at different power settings. How engine response time affected pilot technique. How the absence of propeller torque changed handling during takeoff. This knowledge fed directly into the He 280 design. Third, it established Germany as the first nation to fly a jet-powered aircraft, providing a potential head start in the technology that would define post-war aviation. That head start was largely squandered by institutional indifference and poor resource allocation. But the potential was real. Fourth, and perhaps most importantly in historical terms, it demonstrated that the turbojet engine was the future of aviation. Every aircraft that has flown on jet power since 1939, every airliner, every fighter, every bomber, every business jet, traces its lineage in some sense to what von Ohain and Heinkel demonstrated on that August morning. The He 178 itself was destroyed during an Allied bombing raid on the Rostock facility in 1943, before it could be moved to a museum. The aircraft that changed aviation left almost no physical trace. A few photographs. Some documentation. The memories of the engineers and pilots who were there. Why Germany lost the jet race it had already won. The story of the Heinkel He 178 and the German jet program is ultimately a story about institutional failure. Germany had every advantage in jet aviation development in 1939. The first jet aircraft. Capable designers. Adequate resources. A war that was going well enough to allow investment in future capability. And yet by the time jet aircraft actually mattered to the outcome of the air war, by 1944, when the Me 262 finally entered service, Germany's advantage had been almost entirely eroded. Britain had the Gloucester Meteor in operational service at almost the same time. America was months behind with the P-80 Shooting Star. The 5-year head start had shrunk to near nothing. How? Several reasons, and they're worth understanding because they recur throughout military history whenever a technological advantage is squandered. Institutional resistance. The Luftwaffe in 1939 was optimized around existing doctrine and equipment. Senior officers had built their careers around piston-engine fighters and bombers. Jet aircraft required new doctrine, new tactics, new maintenance procedures, new training. Institutional systems resist these kinds of wholesale changes, especially when the existing equipment is performing adequately. Resource allocation failure. Germany never centralized its jet development under a single authority with real power to coordinate programs, share knowledge between companies, and ensure consistent resource allocation. Heinkel and Messerschmitt competed when they should have collaborated. Engine development and airframe development proceeded on separate tracks when they needed to be integrated. Hitler's interference. The decision to develop the Me 262 as a bomber rather than a fighter, which delayed operational deployment by at least 6 months, is the most famous example of political interference in a technical program. But it wasn't an isolated incident. Throughout the war, Hitler's personal preferences distorted German aviation development in ways that consistently sacrificed long-term capability for short-term political satisfaction. And finally, the bombing. Allied strategic bombing of German industrial facilities from 1943 onward consistently disrupted jet engine and airframe production. The Jumo 004 engine, which required exotic materials and precision manufacturing, was particularly vulnerable to supply chain disruptions caused by bombing. Germany lost the jet race it had already won because it never decided that winning it mattered enough to organize properly. Final thoughts. Erich Warsitz climbed out of the He 178 on August 27, 1939, having just flown the first jet-powered aircraft in history. Ernst Heinkel shook his hand. The small team of engineers who had worked for years on von Ohain's engine celebrated quietly. And then the German Air Ministry, presented with the future, looked at it carefully and decided it could wait. It couldn't wait. It never can. The future doesn't hold itself in suspension while institutional bureaucracies work up the courage to change. It just becomes someone else's future. The He 178 is a monument to what happens when revolutionary technology meets institutional inertia. The technology wins eventually, it always does. But in the gap between when the technology is ready and when the institutions are ready, enormous amounts of potential are lost. Britain's Frank Whittle, working with far fewer resources and far less institutional support than von Ohain, had his own jet engine flying in the Gloucester E.2839 by May 1941. Less than 2 years after the He 178. The British jet program, despite starting from behind, caught up quickly precisely because British aviation authorities took it seriously in a way the German Air Ministry never quite managed. The Heinkel He 178 dynasty that might have been, the He 178 leading to the He 280 leading to operational jet fighters in German service by 1942, existed as potential. As possibility. As what might have happened if the men responsible for German air power in 1939 had understood what they were looking at on that August morning. Instead, the dynasty was stillborn. Heinkel built the future and was told it could wait. The Me 262, when it finally arrived, proved what everyone who had been paying attention since August 1939 already knew: jet fighters were transformative. They were just 3 years too late to transform anything that mattered. The He 178 flew 6 days before World War II began. It might, under different circumstances, have helped determine how that war ended. Instead, it became a footnote, the answer to a trivia question about which aircraft flew first on jet power. Ernst Heinkel deserved better. Hans von Ohain deserved better. And the pilots who flew conventional aircraft against increasingly capable Allied fighters in 1943 and 1944, dying in aircraft that should already have been obsolete, they deserved better too. The future arrived at Rostock on August 27, 1939. Germany just couldn't figure out what to do with it. Until next time, the most dangerous thing you can do with a revolutionary idea is assume it can wait. It can't. It never could. And the price of that assumption is always paid by someone else entirely.